So
Okay.
today's is about using mathematical formulas. So I'm going to share my screen with you so you can see it. And let's talk a little bit about what a formula is. Does anybody, whoa, I always do that. I always give you a sneak peek. Can you think of a formula that you use all the time?
H2O. No, I'm saying.
that is that's a chemical formula, and we use that all the
I
time.
know.
2 hydrogens and 1 oxygen.
Do we do length and height?
Sure. Right. And what does that tell you? When you multiply those two together, what do you get?
How tall and wide something is.
You get the area. So you're multiplying the length and the width, or the length and the height, and that will tell you the area of something. So yeah, that's a formula. So we use formulas to find out area. So and it doesn't have to be just the area of a rectangle. It can be the area of a circle, a triangle, anything like that. We can say how much it holds. So that's volume. And again, it doesn't have to be a cylinder. This is just an example. It can be a cube. It can be prism. Anything that has 3 dimensions we're going to be talking about volume. So whereas the area is just 2 dimensions, length times width, or width times height, or length times height, that's just 2 dimensions. Volume is when we add that 3rd dimension. So we would get here, this is the radius. We're thinking about that is kind of like the length. And we actually square that. So that's 2 dimensions. And then we multiply it by its height. Or if you think about it like a box, you're going to do length times width times height. And that's the 3 dimensions that you get. Okay, so that's volume. Or maybe we want to use a formula that helps us figure out how far we're going, or how fast we're moving, or for how long, what's the length of time we're moving. So all these things are formulas that we know. Generally, we can tell you, if you know any piece of this, if you know the length and the width of something, you can find the area. If you know the length and the width and the height, you can find the volume. If you know the radius or the diameter of a circle or a cylinder, and then you know the height, you can figure out the volume. If you know how far you're going, or how far you went, and how long you were traveling, the time that you were traveling, you can figure out the rate at which you were going. Or if you know how far you went and what the rate was, you can figure out how long you traveled. So these are formulas, are rules that we know. If I know any of this information, I can figure out something else. So these are just the rules of how to find area or volume or distance, those kinds of things. Does that make sense? Okay. So this chart that I took is right from GED. So the good news is that you generally, they're not expecting you to remember these, and you can so you can look them up. So you will have this information there. And that's the good news. I mean, some of them you probably already know, like you told me about the rectangle being area equals length times width. And it's logical to think that if you are trying to do this thing for a square is a special rectangle. You could just multiply length times width of a square. But what do we know about the square? All the sides are equal. So that's why the formula is written as squared, because you're going to multiply the same number. If the square is 10 inches square, you're going to say 10 times 10. And that is the length of the side squared. So that S right there stands for side. Okay. This parallelogram, do you remember what a parallelogram looks like? It's like, I call it a rectangle that is slanted. It's tilted over to the side. So I'm going to show you a picture in just a minute. It's like a rectangle that is slanted. And let me stop sharing. And that's a parallelogram. Okay. Ooh, we lost Tashiana. Let me go back. So these are just all the formulas for area. And we can think of area as a carpet. How much carpet do you need to fill the room to cover the entire floor? So area is 2 dimensions. It will always be in feet squared, inches squared, or meters squared, yards squared, miles squared. It's going to be a length, a measurement of length, and then it will be squared because you're multiplying 2 of those dimensions together. Other kind of formulas are perimeter. So if we are talking about how much fence do we need to go around a yard? So you're thinking about if you start at one corner of a yard and measure all the way around, that is perimeter. So if you have a square, you're just going to say 4 times the length of the side. Or if you have a rectangle, it's the 2 times the length plus 2 times the width. Perimeter, you are adding the length of each side together. So you could say just length plus width plus width. That's the perimeter. It is not a unit squared. It is simply linear because it's only one dimension that you are measuring and adding together. So for a triangle, you're adding the length of all 3 sides. This is the formula for the circumference. This right here is pi. One of the most amazing things about the circumference of a circle is that for every circle, you use this number, pi, and 2 times the radius, and you will get the circumference of a circle. I find that just amazing. The circumference is going all the way around. The diameter goes straight across. The radius starts at the middle point and goes out to the edge. So those are important things to know. We'll talk about that in a minute. Another kind of formula that you can use is the surface area. So with surface area, you're going to think of covering a shape with wrapping paper. So if you have to cover a box with wrapping paper, you're going to need to know the area of every side of that box. So you need to know how big is the top, how big is the bottom, how big are the two long sides, how big are the two short sides, and you add all these together. So this is the formula for surface area of a rectangular prism, which it means a box. And all of these surface areas are three-dimensional figures. So we've got a right prism, which I'll do another video on this, and I will show you some of these figures. We're not going to use some of these right now today, but a cylinder, looks like a can. These are the ones we're going to be talking about today. A cylinder, which looks like a can, and a rectangular prism, which is a box. We're not talking about a sphere, but you know that a sphere is a ball, and a cone is like an ice cream cone. And these two are, this right prism and the pyramid, are sometimes confusing. We'll talk about those on another day. But when we're talking about, surface area, we're thinking of covering with wrapping paper. We're thinking about volume. We're thinking about how much water could fit inside. Okay. So we're talking about the amount of space that is inside a three-dimensional shape, like a box or a can or a ball. How much air is inside a ball. So that's what volume tells us. So which formula would I use to answer these questions? How much sand can I put in the sandbox? What are you talking about there? Would I use area, surface area, volume? Distance?
Surface area.
No, we're talking about how much can go inside a container.
You use volume.
Say that again, Tayshana.
Volume.
Yes, when we're talking about how much can we put inside, we're talking about volume. Beautiful. I want to paint my room. What do I need to know when I go to buy paint and I want to know how much paint I need? What do I need to tell the person at the store?
The area of your room.
The area. Yep, because I want to know on the can, it will tell me how many gallons I need to cover so many square feet. So I need to know the length and height of the walls of my room. And that will, if I add them all together, that will tell me how much paint I need. I want to put molding around the bottom of my room, like where the floor meets the wall. I want to put molding there.
The surface.
Surface area, we are thinking about something that is three-dimensional. This is just around the outside of my, or around the floor of my room.
The perimeter.
That is perimeter. So it's almost, think about, I'm building a fence around a yard. I'm putting molding around the bottom of my room, around the floor. So that's perimeter. How much water can I put in the cooler?
You trying to find a depth?
Say that again.
So that's volume then.
That's volume. Correct. So if I had a big, I'm thinking of like a huge thermos, like you would carry out for a team to get little cups of water out of, that cooler. Yeah, how much water can I put in there? That would be volume. How much material do I need to make a tablecloth?
Like width, length,
Right? What do we call that?
area.
Area. Beautiful, because I want to know the length and width of my table. And so that will tell me how much material I need to, and I probably want it a little bit bigger than that because I want it to hang down over the side. So then I'm going to have to add some extra to each side. But that will give me the area that I need to cover. Beautiful. How about how much material do I need to recover my sofa? So I don't like the material that's on my sofa. I'm going to recover it myself. I don't know if you've ever done any upholstery work. It's really hard. But what do I need to know to recover my sofa?
The length and the width.
I'm going to need to cover that would tell me, like, the length and the width might tell me, let's see, I'm measuring the back of my sofa. But I also have to measure, I also want to cover the front of my sofa, the sides of my sofa.
So the whole perimeter of the couch.
Perimeter would just tell me a single length of measurement around. It wouldn't give me the 3 dimensions that I need.
Is it the whole area?
We call that surface area. So because I want to cover
Oh,
the back, the front, sides, I'm going to measure all those areas and then add them together to get my surface area. So it's a series of measurements. So if you think about your sofa, it has a back, it has a front on it, but it also has sides that I'll need to measure. So I'm gonna measure the length and width of each of those pieces, and then I'm gonna add that together, and that will give me surface area. Okay, so an important part of using formulas is understanding which formula I need to use. Because in a question, they may or may not tell you. Sometimes the answer will help, or the question that they ask you will help you out. Sometimes they'll say, what is the volume of the cooler? Or what is the area of the room? And so that tells you right there which one. But if they're asking you something like, I want to put molding around the room, how much should I buy? You need to understand the perimeter, and that's the formula you need to use. Okay, let's take a look at the next thing. So this says, so using a formula, once I have a question and I know what I'm doing, how do I work with that? So if the question is, how much carpet should I buy to cover the floor in my room that is 12 feet by 8 feet? We said, if I'm going to cover the floor, that is thinking about area. And we're going to, if it tells me that my room is 12 feet by 9 feet, then I know that it's a rectangular room. There's nothing unusual about this shape. It's it would have to say if it was a triangular shaped room or I'm actually sitting in a room that it is not a rectangle. It's got a little piece cut out of it. They would have to tell me that, but they just said it's 12 by 9. So I'm going to assume that it's a rectangle. It's a normal room. So here's the formula. I know that the formula for the area of a rectangle is length times width. I substitute in what I know. I know that it is 12 feet by 9 feet. I substitute in 12. We usually think of the longer dimension as being length. Truthfully, it doesn't really matter as long as you get the two numbers in there. And the width is 9 feet. And then I just do the multiplication. I solve. 12 times 9 is 108. What did I do wrong here? What mistake did I make? And it's not. Say it again.
You didn't put what it is. It's 108 what? It's 108 feet, 108 dogs, 108 cats.
Beautiful. And so and we call that units, identifying your units. So what unit should I add to my answer to make it completely correct?
Feet.
Feet. Feet what?
Square.
I've multiplied two dimensions, so it's got to be what? Feet. Tayshana, I think you said it.
Feet to the
Feet squared. That is a 2. It's a bad 2. 2. Okay. So yeah. So you always need to use your units. Thank you for knowing that. And I can't believe I forgot, but I did. It happens, right? So yes, because we're multiplying two units together, or two dimensions together, we get feet squared. So they're going to be all units together, feet squared. Okay, let me get to, there we go. All right, next one. Here's our next question. How much space is in a storage locker that is 10 feet by 10 feet and 8 feet high? So first of all, let's start by what formula should we use?
10 feet by 10 feet. Length times width, or no, width times height. No.
We're talking about how much space is in a storage locker. So if I'm talking about the amount of space inside something, what formula does that automatically tell me I
do the, I can't remember what it's called. Surface area.
Nope, that tells me how much is around the outside.
Okay.
I want to know what's inside.
Volume.
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 Oh.
Yep, when I want to know how much is inside, I'm using volume. So the formula for volume, this is, because it's telling me it's 10 by 10 by 8, that's telling me that it's like a cube or a box, a room. It's and width and height. So that's the formula for volume. And what do I do now that I know which formula I'm using?
You solve it.
Well, first I'm going to do something before I solve.
You gotta multiply?
Substitute in your known values. Okay?
Oh, substitute. Oh, yeah, substitute the numbers.
Yep.
Oh,
And then
okay, yeah.
10 times 10 times 8 is 800.
Beautiful. Then you solve. So substitute in.
800 to the third, no, that's not third power.
Yes, it is.
Oh,
Yes, it is.
okay.
You
So
got
is it the third power because it was 3? Is it the
Yes.
third power because, okay.
Yes, indeedy. That's right. So just think
Okay.
you multiplied exactly 10 feet by 10 feet by 8 feet. So you did feet times feet times feet. So that is feet to the third power. We also call it feet cubed. And if you think about it, that makes sense because a cube is a three-dimensional rectangle. It's a rectangle that we also have that third height. So we think about it as being a box. You know, a tissue box is a cube. But a room is actually a cube. What else can we think of that's a cube? I'm looking at a chest here that's three-dimensional, so that would be a cube. It's a rectangle.
Building.
A nightstand can be a cube.
A what, Ken?
A nightstand.
Yes, absolutely. If you think of a semi-truck, the back of the back of the truck where you put all the stuff inside, that is yeah.
A building.
So that's how you use a formula for volume. Another one. I don't want to do that one yet. How much paper do I need to cover a box 12 by 8 inches and 2 inches wide?
Okay. Divided to cover by say 12 inches by 8 inches and 2 inches.
You're thinking about covering a box with paper, so you want to think about it. You're wrapping a gift.
The perimeter around, like the area around it.
Well, it's not perimeter. It is area, but what kind of area?
The surface area.
It's surface area. I don't think I put that on here. Let's think. I'm gonna stop sharing my screen here for a minute, and we're gonna figure this one out together. So, do you remember the formula for surface area?
No.
No. But let's think about it. So I've got a box that's three-dimensional. And so there's my box that's three-dimensional, and I'm going to cover it with paper. And I know that I'm going to figure out, I have to do it by figuring out the area of each. So I have to figure out the area of the top and the bottom. So to figure out the surface area, I've got to figure out the top and the bottom. So what would I use to figure out how big the top and the bottom are?
Base times height.
You got multiply length. She said multiply length times height.
Well, for the top and bottom, I need to do, oh goodness. Yeah, for the top and the bottom, I agree with you. I need my length, but what's the other dimension? That's a
Width.
W for width.
Oh, I didn't see the W up there. Length and width. Length times width. Base times height. I didn't see the W up there.
Yeah. So I've got length times width, and that would be my, and the bottom would be what? The bottom is the other side. It's the same.
Yeah, plus base times height.
The bottom is going to be the same as the top. So that's length times width again.
Mm-hmm.
And
That's the height.
I've got the long sides. So I heard somebody say length times height. So that's going to be my long side. I have two of those, right? So I've got times width, the bottom.
Okay.
One side is going to be length times height. And then I need two more sides, right? Those short sides. So what do I need to multiply together to get my short sides? My short side, think about this one and the one opposite it. So the one that's
it's gonna be the length and the width. I mean the length and the height.
We've already
The
done
width and the
that.
height.
The width and the height.
Width and the height. That's the short side. Beautiful. And I'm running out of room because I never remember myself enough room. Okay, so I need a bigger board. So I've got length plus width, plus length plus width, plus length times height, plus length times height, plus width times height, plus width times height. That all makes sense to you, right? You understand where that comes from. So if you didn't have
because
the
you have to. That's where the surface comes from. You got to get the whole entire. It's more than one measurement. That's why.
Correct. But we could make this simpler, couldn't we?
Yeah.
Because couldn't I say that if I have length times width and length times width again, couldn't I just multiply that by 2? 2 times length times width, and 2 times, I'm going to make these L's, cursive so that you can tell, because that's confusing. So couldn't I say, if I have to add those twice, couldn't I just do that once and then multiply that by 2? Does that make sense?
Okay, well, it is the same thing. Yeah, basically, that's what's on that thing.
Yeah. So that you just found, that is the surface area formula. You just figured it out. So if you can't remember what the formula is, if you stop and think about what you need to do, you will be able to figure it out. Okay.
Mm-hmm.
So you just, what I want to emphasize is that you don't have to memorize this. You need to stop and think about what it is you're trying to figure out, and then it will be clear to you what you need to do. So if you're thinking about volume, you're thinking about, I have 3 dimensions, so I'm going to multiply those 3 dimensions together and get the volume. If I'm doing surface area, I'm figure out the area of all the sides that I need to cover, and then I'm going to add those together. So when you're this, don't be confused here, because you're only multiplying 2 dimensions at a time. So your answer is going to be, let's say that, well, in this problem, it was inches. So when I do all this work and I come up with a number, which right now I'm going to call the surface area equals X, because we haven't done our work yet to figure out what it is. What's my unit going to be? It's in inches. Are they 9 inches or inches squared or inches something else?
You said will it be inch? I think it'd be inches squared.
You are correct. Because we're only multiplying 2 dimensions at any time, and then we're adding them together. And your other clue is that it's surface area. So we still have area in there. Even though we're adding them together, we're still just doing an area problem. Okay? So let me see, what did we say? It was 12 inches by 8 inches by 2 inches. Do you want to figure that out? What is the surface area? So we can take this formula that we had, and we know that our box is 12 by 8 by 2. And you let me know if you come up with a solution before I get there.
You talking about, so we'll multiply them, the 12 times.
So I'm rewriting our formula right now so that you can take a look at it.
Okay.
Oops. Length times width, 2 times width times height, and 2 times length times height. Okay. So that's our formula.
Okay.
2 times length times width, and 2 times width times height, and 2 times length times height. And we've got 12, 8, and 2. So I'm going to call 12 is the length, 8 is the width, 2 is the height. Okay? So you just substitute in and solve.
Okay. Okay, so I got, okay, so let me see if I got this correct.
Okay.
See if I know what I'm doing.
And I just use parentheses to tell me to multiply.
By 2.
Yes. Well, I'm going to say.
Okay, see, that's exactly what I was about to ask you. I was about to ask that exact question of how am I supposed to solve it. So do I multiply both numbers? Once I get the answer to both numbers, I add, what do I do next? Because it's going to be 2 separate numbers, right?
Right. So you're going to say, you can do, because multiplication, it doesn't matter which order you do it in. You can either do 12 times 8 times 2, 12 times 8, and then multiply that by 2. Or you can say 2 times 12 times 8. So whichever way you want to do that. I'm going to put that in my calculator.
I got 432.
You got 432 by doing it all the way?
Mm-hmm.
Okay.
Okay, I'm still working on mine.
Let's see. I'm gonna take this step by step, okay? And I'm gonna show you how I do it, just to be sure that I don't make any silly arithmetic mistakes, because it is very easy to do that. So I solved 2 times 12 times 8 and got 192.
Okay, right. I got that too.
Okay, and then I
You
said
get
is 16 times 2 is 32.
Okay. Right.
And then I
two.
said 12 is 24
Oh,
times 2 again is 48.
okay. I thought the middle one. I thought that 2 was a 12 too. So yes, my answer is wrong.
Okay. Okay.
So basically we okay, so you 12 times 8 times 2, like that. Right?
Yep. Mm-hmm.
Okay. I got you.
Okay. Cool. And then now what do we do?
We add all of those up together.
Perfect.
12, 13, 14, 15, 16. I got 262.
I got 272.
So who's right?
I don't know.
I'm about to tell you who right in a minute. Hold on, wait. 192
13, 14, 15, 17, yeah.
plus
272.
plus 48. 272.
272. 272. 272 what?
Feet. Square feet. I mean, not square feet.
What's that? I can't see it.
Let's go back to the problem. It says, how much paper do I need to
Inches.
cover a box that is
It's
12?
inches.
So the answer is
272 inches.
inches. I'm talking about area, so my inches are going to be,
3 squared.
To the third, yeah. Yeah.
did you say to the,
Why is it 2? Why is it 2? Oh, no. Why is it 2?
why is it 2? Why is it squared? Because all we did was apply 2 dimensions and then add those together. Remember, this is surface area, so still area. And in each case, when we figured out the area of the top and bottom, we still figured out we multiplied 2 dimensions, length times width. Then when we figured out the area of one side, we did height. And then when we figured out the area of the other side, we did length times height. Added them all together. Each time we figured out an area,
8, 9, 10,
by 2 dimensions together. That's why it's squared.
10, 11, 12, 13,
Does that make sense?
17.
Yeah, kind of. I'm going to have to go
Okay.
look at it again.
That's okay. So then, but just think about it this way. Anytime, like to make this exponent go up, this exponent is telling us how many dimensions we've multiplied together. And even though we've multiplied these dimensions several different ways, in any one of those little pieces, we only multiply 2 dimensions. So 2 dimensions
Okay.
here, 2
Yeah,
dimensions
the
here, 2
surface
dimensions.
area is 2 dimensions.
Right. So we're just finding the area bunch of different sides of this box and then adding them together.
Okay.
So, you know, of a box has 6 different sides. So we figured out 2 of, you know, it's 3
What?
pairs of
No.
sides, so there's 6 altogether. But we're still just figuring out the area. Okay.
Okay.
Well, beautiful. That takes us right to 10 o'clock. So I think next week we'll do another lesson that continues with the same idea of formulas and get some practice and
Okay.
sense. So we'll practice with figuring out which formula should we use, and then how do we do it, and then what units does that tell us we need to use.